In this video, we're going to focus on the relationship between the times 3 and times 6. So times 3 can be thought about as being one group more than the doubles fact. So 3 groups. If I know 2 groups, I can do one more group. So if I don't know my times 3s, that's one way that I can be thinking about it. Now, once I've mastered my times 3s, there is one relationship of a times 6 that may be powerful as well. If I know my 3 groups of that other factor, I could double it to get my 6s. Now remember, we're not having a dictate of you must use this certain way of thinking. It's not that we're telling students when you see a times 6, you must do double of the times 3s. It's just one option, and one option that might speak to the child. If they know the times 3 relatively easily, they can think, oh, I could just double it to get to my 6s if I don't yet know my 6s. But personally, I love using times 6 as being 5 groups and one more group. And again, my 5 groups is being half my 10 groups. Life-changing. But again, it's up to the students of what relationships make the most sense to them. But a really powerful connection is that times 6 is double of the times 3. Let's begin with exploring the multiplying by a 3. So many of our students do learn their doubles. And so we can capitalize on that knowledge by thinking about 3 groups as being one more group than the doubles. So rather than a memorized fact, we can relate it to this understanding of multiplication in one way as being equal groups. So visually, we can see here with these cubes, there are 3 groups, each having 6. And I did intentionally put these 6 cubes in a supertizing pattern. We want students as often as possible to be able to tell at a glance how many are there without having to count. It might match dot patterns on dice. It might be like a 10 frame, some way that the students can tell how many are there without counting the one by one. And so here we have 3 groups of 6. And if I already know 2 groups of 6 is 12, I only have one more 6 to go. So I can think 12 plus 6 more then makes the 18. We also can use Cuisenaire. Remember my favorite manipulative. They have the benefit of the students seeing these numbers existing as a group, which is a lot different than them seeing it like an array and having all those individual x's, particularly as we get into the larger factors, because it becomes really inefficient for them to be counting and not visualizing them as groups. So here we have 3 groups of 7s. I've got 3 7s. So I might say, well, do you happen to know what 2 7s is? And if they know 2 7s is the 14, we can then work on, well, what's one more 7 than that? And that's where their additive strategies can come into place of decomposing a number to be able to make a nearest 10. So a 14 plus a 7, I can think, well, it takes 6 more to get to 20 because 6 and 4 make a 10. And in that 7, if I take 6 to make that 20, there's one more left. So it's going to be a 21 in all. So I can derive and figure out that this is 21. And if I have some time that I can be exploring and mastering those facts, well, then when I'm asked 6 groups of 7, so if I copy these 3, and then I just do it again, we can see that we've got 6 groups of 7. But if I already know that 3 groups of 7 is 21, then what do I have left for the 6 groups of 7? Well, it is another 21. And as we come to the Rec and Rec, I love the Rec and Rec for exploring this flexibility with the factors to explore all different relationships with it. Now we are focusing in this video on 6 doubling of the 3s, but I want to do a little time also on this times 6 as another way we can think about it. So let's figure out 6 times 8. I have slid over 6 rows, each having 8 beads. Hopefully you can see how the color coding, I could do that without having to count one by one. I know I have 6 rows. It's 1 row beyond the 5. And I know I have my 8 because it's worth 5 and 3 more. Or maybe I also know that there's 2 over here. So that must be 8, right? A variety of ways for us to build this number sense with these quantities. So 6 groups of 8. And remember, we can think about, well, do you know 3 groups of 8? Because if you know 3 groups of 8, and that's something that you can retrieve from memory, I know that that's 24. And what do we have left? Well, indeed, right, this doubling relationship, 6 groups is double the 3. I've got 24 and another 24, which of course makes my my product of my 48. Now, what I also love though is how these beads allow us to flexibly explore. Just want to show you a few more possibilities to show that, again, it's never a dictate of what we tell the students, you must do it in this way. So when we think about 6 groups, I also love thinking about 6 groups as being 5 groups and then 1 more group, because I've really used 5 groups being half of 10 to multiply so many things, including decimals. It's so much easier. So I know I can do times 10 and half it. 10 eighths would be 80. So half of that would be 40. So 5 groups of 8 must be 40. And then I have 1 more 8 to go here. So I know I have my 48. So I'm breaking apart my 6 into 5 groups and 1 group. This is the heart of distributive property and multiplication, that I'm breaking apart a factor and distributing it to the other. That will graduate to place value as well as the numbers get larger, but we also aren't limited to only by place value. And another way students might want to think about it is, well, if I know 2 groups of 8 is 16, I have another 2 groups and another 2 groups. So we can think about 6 groups as being triple of the doubles. So variety of ways for our students to think about how we can break apart 6 to be able to derive it until we, of course, master it and we can retrieve it from our memory.